genetic data are very distributed in different files, in different organizations. There are people working on neutral markers, there are people working on adaptive traits, people working on conservation unit, and this information is completely distributed. Okay? Now this project will assemble this data so that the users can rapidly have an overall picture of what's going on.
We are currently selecting the data all over Europe. That has been never done before from a historical point of view, as well as we detected that we do not have on a European scale data at hand that provides information on the translocation or the movement of forest reproductive material within Europe.
Let's say my dream would be, to try to collect within this project data on molecular markers, and when I am referring to molecular markers, I am referring to neutral and potentially adaptive molecular markers on adaptive traits. And a third set of data about climatic parameters. So having these three data sets, I'm expecting to be able to monitor diversity.
We are facing a big problem of heterogeneity of data. So it's difficult to get sense out of it and to interpret correctly the data that have been obtained.
Field data and molecular investigations can be bridged. This was a problem I was facing all my life, and I'm very happy that I can participate here in this big experiment to bring this together.
The combination of this kind of information can be extremely useful in terms of management.
If we find non-genetic indicators but are important for the genetic, then it might be very easy to implement this in management or apply it easily by foresters. You can use cost-effective methods to know, okay, what is the genetic diversity in my stand and how it will evolve.
We do not have information on the translocation of the material across Europe. That is very important to draw some conclusions, and that's very important also for the forest management, because as you can imagine, very often the wrong seed source is used, and then you run into a disaster and you cannot explain why, and that certainly would help.
There are potentially many applications. I would start from the most simple one, is tracking the origin of the material. The second, identifying some hotspot of diversity which might be of adaptive significance. So designing gene reserves or management units based on traits which are related to adaptation is extremely important. Then of course also identify gene zones. It might be extremely important in terms of management.
The loss of genetic diversity is certainly not such a vexing question for the normal everyday manager. But if you explain him that, for instance, this very far issue of genetic diversity is linked with climate change as a possible thing, then it is easier. It's still not simple, but it's a little bit easier to convey this message.
Because climate change is moving so fast, actually we can move the material around at the same speed by artificial plantation, but you have to know where and how. And we can answer this question by using results of provenance tests, because provenance tests resulted from moving of material. Provenance have been moved 100, 200, 300 kilometers from one climate to another, and we can make use of this information to take measures to anticipate the effects of climate change. I think so. This is a very important issue.